Okay, so today we're going to be learning about squares and cubes. So we'll be doing lesson 17 and 18. So let's investigate perfect squares and cubes. So it says just listen and watch. When we multiply two of the same numbers together, like 5 times 5, we say we are squaring the number. And we can write it like this. So technically 5 squared just means 5 times 5. Okay, so it says because 5 times 5 is 25, we can write 5 squared is equal to 25. And we say out loud, 5 squared is 25. Then it says when we multiply 3 of the same numbers together, like 4 times 4 times 4, we say that we are cubing the number. So we can write it as 4 cubed, or 4 to the third power. It says because 4 times 4 times 4 is 64, we write 4 to the third equals 64. And what we would say out loud is 4 cubed is 64. So what you need to really take from this is that when you're squaring, there's going to be a 2 at the top. And when you're cubing, there's going to be a 3 at the top. So it says we also use this notation for square and cubic units. So a square with a side length of 5 has an area of 25 inches squared. And then a cube with an edge length of 4 centimeters has a volume of 64. So we're going to be dealing with area and volume. So this is just a quick recap. So the exponent. The exponent is the little number that you're seeing on top. So in expressions like 5 to the third and 8 to the 2, the 3 and 2 are called exponents. They tell you how many factors to multiply. So for example, 5 cubed, or 5 to the third, just means 5 times 5 times 5. And same here, 8 squared, or 8 to the second power, just means 8 times 8. The most common error is that kids will do 5 times 3 and 8 times 2. And that is not what that means. So don't get those confused. All right, so squared, we use the word squared to mean to the second power. This is because a square with side lengths s have an area of s times s, or s squared. So this should be times. All right, and then same thing here. Cubed, it says we use the word cubed to mean to the third power. This is because a cube with a side length s has a volume of s times s times s, or s to the cube, to the third, which is s cubed. Okay, so now we're going to be talking about perfect squares. So you're in your book and you're on page 106. Okay, so some numbers are called perfect squares. Not all of the numbers are perfect squares, and these examples that you see, these 3 in the middle, those are examples of not perfect squares. Now the number 9, it is a special number. It is a perfect square. As you can see, this is a 3 by 3 square. Well, 3 times 3 makes 9. So that is what makes it a perfect square. Notice how its square is exactly that of a square. Okay, so you're still on page 106. And then we're going to answer number 2. So a square has a side length of 7. What is its area? So I kind of made a picture here for you. So if one of the lengths is 7, I know that the other length is 7 because it says it's a square. And then you know area, 7 times 7 is 49. So you should at least write 7 times 7 equals 49. All right, still on page 106, and I'm doing number 3. So it says the area of a square is 64. What is the side length? So we have done this before, right? If I know that the inside is 64, I need to figure out what times what makes 64. Well, I know that 8 is the answer. So I would do 64 divided by 8 equals 8. So this side would be 8 and this side would be 8. And then if you want to check your work, 8 times 8 makes the 64 on the inside. So under number 3, you're just writing the 64 divided by 8 equals 8. All right, so you're still on page 106. Now we're going to cube them, right? So now we're moving on to the newer part. So you're still on page 106. Some numbers are called perfect cubes. The number 27 is a perfect cube. So notice that this is 3 by 3 and the height is 3. So 3 times 3 times 3 makes the 27, and that's what makes the number 27 a special number, which is a perfect cube. Notice how there's no other squares outside of this cube. All right, so now you turn the page. You're on page 107. So I'm doing number 2. A cube has a side length of 4. What is the volume? Now remember that volume is the length times the width times the height. I want you to write that in your book under number 2. So if I know that one of these sides is 4, I know that the height is 4, I know that the width is 4, and I know that the length is 4 because it is a cube. They're all the same sides. Okay? So what I would do is I would do 4 times 4 times 4. And then you would get 64. So 4 times 4 times 4 is 64. So notice that when I cube it, I find the volume. And I just do the length times the width times the height. That is how we find volume. Okay, so now I'm going to be on number 3 on page 107. And it tells me that, well, one of the sides is 10, but it's a cube. So I know that all of the sides are 10, right? So it says a cube has a side length of 10. What's the volume? Remember that volume is length times width times height. So we're going to multiply 10 3 times, pretty much. So 10 times 10 times 10. And that's 1,000. So on number 3, you should write the length, width, height, and 10 times 10 times 10 is 1,000. All right, so now I'm going to switch this. So now we're going to be finding the surface area of a cube. And this is lesson 18. So it says, let's write a formula to find the surface area of a cube. So here we go. You're just listening right now. So the volume of a cube with edge length S is S to the third. So S times S times S, right? So that's the formula. And that's the volume of a cube. Now, I added this for you so you can see it with real numbers. Okay, so this length is 3. That's where I got that 3. This length is 3. That's where I got the second 3. And this height is 3. And that's where I got that third 3. So what you do is you do 3 times 3 times 3. So what I do is I do 3 times 3 is 9. And then 9 times 3 is 27. So the volume of this cube is 27. So remember, with volume, you're just multiplying all 3 together. All right, so now we're going to do a quick little review on exponents, and this is the last little part. So you're on page 111 in your book. So on page 111, it says, select the greater expression of each pair without calculating the value of each expression. So this should be a times. For whatever reason, the little equation didn't carry over. So the top one, or the left, I should say, on A, is 10 times 3. Well, I know that 10 times 3 is 30. Okay, so that's that one. And then now I need to figure out this 10 cubed. So remember, that is not 10 times 3. That is 10 times 10 times 10, right? So let me write this out. 10 times 10 times 10. So 10 times 10 is 100, and then 100 times 10 is 1,000. So what they're asking you to do is, which one's bigger? Which one is greater? And so your answer would be 10 to the third. So this one here is the bigger one. Okay. And then now I'm on B. This should be times, right? So now this one is 13 squared. Remember, that is not 13 times 2. That's 13 times 13. Okay, so 13 times 13 is 169. Okay, and then now I'm doing 12 times 12. So 12 times 12 is 144. So it says, which one is greater, 13 squared or 12 times 12? And the answer is 13 squared. So that would be the one that you circle. Okay, and then our last one here. Again, this is times. The equation didn't carry over. So 97 plus 97 plus 97 plus 97, 97, 97, which really is 97 times 6 is how I'm going to do it, is 582, or 5 times 97. And I think that's obvious without even working it out, but that's 485. So it wants to know which one's greater. This one's the bigger number. So you would circle all of that for letter C. So come join the meet and we're going to practice this more.